Hello, welcome back. So today I'm going to go over the stream or from last Tuesday and show you what we've been up to. And so maybe quick recap of the recap. So we had looked at this last week. So looking at going through the outputs of CheckM2, it's very based on KOs, and so we had seen that as the number of mutations increases, we have both more false negatives, that means KOs that are no longer there compared to the wild type, and more false positives, that KOs that are falsely reported as being there. And so both of these lines go up, but do pay attention to the scale. So the number of false positive KOs, that's 50, and there's a 400 there in the number of missing KOs. So most of the errors are KOs that are now missing. So this week we explored a little bit more of this, sorry about that noise, about this, and we looked at these, we wanted to look a bit deeper, so let me set these things up. And first we explored a bit. First we wrote this function, which I'm just gonna show you quite. Let's look at this. So this is the output of Prodigal. That's as reported by CheckM2. So here we have FASTA file, so the greater than symbol, ID, and then this is start, end position. This is the strand, and then more information. We mostly care about start and end because we just want to get the length. So here we're going to look at the wild type, 0 mutations. We're going to look at 100 mutations, and we're going to look at 1,000 mutations. So let's just load all of the data, and this is actually now going to fail for a very, very specific reason, and I will show you in a second. The reason this is failing is, if we look at here at the diamond output of CheckM2, previously the diamond output was split into multiple files, but one of the changes in this session was that we've changed to now run from 0 to 5,000 mutations by steps of 25. This is a little bit more realistic than what we were doing before. Before we were doing up to 50,000 mutations, a little bit to force the phenotype, so to speak, to try to really try to see if we got something, but this is a more realistic regime. And so now in this regime, we no longer have diamond results being split up. We have a single diamond results file, and then let's and remember, this is what it looks like. So here, this is the input file, then this sigma, the arf, and then this matches something, the tilde, and then the KO, so the Kank orthologous group. Right. So we're gonna now parse this. So let's just name things, and then parse. So here we're gonna split up the query into along the omega symbol, so first the genome, then the ARF, and then we split the subject and on the tilde, and actually we only care about the KO, right? So let's look at these three. So wild type, 100 mutations, 1,000 mutations. Let's get the KOs. Let's get the ARF positions as well. And now I'm gonna just run the loop and then talk you through it. So now we look at KOs that are present in all three, and then we only select the ones where there's a single ARF to KO. This could be done slightly differently, but this is the easy case. It's also the most common case. We can actually check the other cases, and then we just look at the lengths. And so I'll put this into a data frame, and then just look at the ones where there's a difference in lengths between the wild type and the 1,000. Let's just now do a plot. Let me just bring up there it is. Okay, let's first just put a box plot with everything. All right, and if we look at a box plot with everything, so with 1,000, you see that there's a decrease, but between the wild type and the 100, if you actually just looking at the box plots, this is if we did a Mann-Whitney test, so then this is not significant difference. I checked. If we do the paired Mann-Whitney, so the Wilcoxon test, then there is a difference, but it's really not easy to see. But if we now look, so these are the KOs, the individual KOs, and they're being colored by green means that, so we're comparing the wild type to the 1K, so green means that the length went down by at least 100, so K is the length went down, but by less, basically less than 10, so that means that, so gray means nothing happened. Red means the length actually went up, so you can see there's a fair amount of red, probably more at the bottom end than anything else. But it's even when we compare wild type to 100, you see some very large drops, so some very significant drops there. So this is what we ended up with. So this is still very much work in progress. So I wanted to explore the data a little bit before committing to something, to a particular analysis. So this is also why I've committed this code not to the main repository, but to where is it? But there it is. But the work in progress repository. So if I go. If I go here, this is in this work in progress repository. So if I was working on this project, outside of the stream, I would actually not even have committed it. I would keep working on this for a little bit longer. At the very least, we would want to have this be, maybe a little bit more generic, running over multiple genomes. Maybe not just hard coding these 3 positions. So this is not great code for now. But for exploration it works, and it does show that we have, I think there's something here. So if these green, this one, we see big decrease. I mean, actually this one goes up afterwards, which is kind of interesting. But there's a big decrease even just with 100 mutations, and with 100 mutations, so CheckM is still saying that this genome is basically perfect. And so if we could capture this effect, I think we could capture something about the quality, because this genome is still very good, but it's less good than this one. Right. So that's what we worked on today or this week. We'll keep working on this next week. Trying to explore a little bit more. We're still in this. There's a phase of the project where we're just going to be playing around with this. In July, I'll have a fair amount of travel. Maybe I'll get to see some of you out there if you happen to be at ISMB in Canada, or if you're in San Francisco, or if you're coming here to Brisbane. So maybe in July we'll have a little bit of a break with the EOS project. But until then, keep in touch, subscribe, shoot us an email, show up on Discord, and talk to you soon.